Okay, sorry guys, I should have had this ready before I started, but I didn't. Pull that to the front and make that large. Okay, so you're going to need your calculator today in case you cannot tell. We are going to be talking about graphing exponential functions today. So in your notebook, it's labeled on page 52, 15.4, graphing exponential functions. We're going to do the same pieces where we're going to find A and, well, this one will be A and B, and the x-intercepts and the y-intercepts and the end behavior and the domain and range. The difference in this one, though, is we're not going to be able to graph this just by looking. We're going to have to use tables to graph exponential functions. So within this, you have a foldable, so you're going to need to grab that or write on page 52. I've got it right here. Okay, graphing exponential functions. So an exponential function has two pieces. It has A and it has B. Right here we have y equals A times B raised to the x power. An exponential function is like an explosion. Okay, it's going to start out really small, and then it's going to go up really quickly. Okay, so first of all, we're going to identify some things, and then we're going to make a table. Then we're going to find the x-intercept, the y-intercept, the end behavior, the domain, and the range. Okay. The A value is always the first number, that is 3. The B value is always the second value. That's how you identify A and B. The rest of these we are going to have to do by graphing. Actually, in a minute you'll see we know the x-intercept and the y-intercept without graphing, but that's not the point. All right, to get a table, it's been a while since we've gotten a table on our calculator, so I'm going to give you a quick refresher. To get a table, we press y equals, and then second, and then graph, okay? So go to y equals, clear anything out if it's there, 3 times 2 raised to the x power. So that was the y equals part. Now we've got to do the second and graph. Second, graph. Here we go. All right, we're not going to put all those values in. We're going to start. We're going to do -2, -1, 0, 1, 2, 3. Okay? So I'm going to go down. -2. -2 is 0.75. Number 1 is -1 is 1.5. 0 is 3. 1, 6, 2, 12. I got some terrible eyesight. Evidently, I got to go down to see 3. And 3 is 24. We talked about this in the past. We can only graph the ones that this graph has. This graph goes up to 20, so we can graph as much or all of these. So -2 and 0.75 is right about there. It's very close to 0. -1, 1.5, not quite at 2. 0, 3, 1, 6, 2, 12, and we cannot graph 324. You are going to need to go from left to right and draw and connect all the way up to the top. Okay, now let's talk about the x-intercept. Where's this cross the x-axis? I'm going to look up. I can actually look in my table. So where it crosses the x-axis is the x-intercept. It does not cross. Remember, from absolute value, if it does not cross, we write none. You don't leave it blank. I need to know that you understand it's none. The y-intercept. It crosses at 0, 3. We're going to notice something about this as well. So it's right here in this graph. It is also always A. A is always the y-intercept. All right, in behavior. In behavior is a little different because it does not have an x-intercept. Okay, in behavior. When x is going in this direction, y is never going to get down to the negatives. It's going to get as close as possible to the number 0. Okay? You will always have a 0 in an exponential function in behavior. It will depend which one. You'll see that in a minute. The y values are going up, so they are infinity. Okay, domain. It is pointing both left and right. That is all real numbers. Range. It never goes below the positives. So it is y is greater than 0. It is not or equal to, because it does not actually touch, okay? That is how we do exponential. Open that up. We're going to do 2 and 3 and 4 and 5. Number 2. A, -2. B, 3. X-intercept, none. If it doesn't have plus or minus, it's none. The y-intercept, 0, -2. I know that because that's what A is. Now let's graph. These are the x values we're going to use every time. Go back to y equals, clear this out, and type -2 times 3 raised to the x power. Second graph. -2 is -0.2. -1 is -0.7. 0 is -2, like I told you, the y-intercept. 1 is -6. 2 is -18. 3 is -54. We'll be able to graph them all, but the last one. -2, -0.2 is very close to 0. -1, -0.7 is a little closer. 0, -2. 1, -6. 2, -18. It's never going to cross that x-axis. The end behavior, though, when x goes towards the negatives, this left y is going towards 0. When x is going towards the positives, the right side here, y is going towards the negatives. The domain is all real numbers because it's pointing in both directions. The range is y is less than 0 this time because it's the negative numbers. We're going to do number 3, then I want you to pause the video and do the others. A is 2, B is 4, the x-intercept is none, the y-intercept is A. Y equals, clear this out, 2 times 4 raised to x. Second graph. 0.125, 0.5, 2, 8, 32, 128. That one gets really big really fast. By the way, these are also geometric sequences. That's why we did that first. Geometric sequences are exponential. Okay, -2, 0.125, -1, 0.5, 0, 2, 1, 8. I can't even graph that one, which means I don't need to cross this. I need to keep it going and not cross because it doesn't cross till 32. In behavior, when x is going towards the negatives, the left over here, y is going towards 0. When x goes to the positives, the right side, y is going towards infinity. All real numbers. The range is the positives, so it's greater than 0 this time. So pause the video and do 4 and 5. Number 4. A is -2. B is 4. X-intercept is none. That will change when it's positive and negative. You'll see that later. Y-intercept is A. That can change if it's positive and negative. In behavior, we'll find that out in a minute. Domain is all real numbers always, and range is something compared to 0. -2, negative 1, 0, 1, 2, 3. Y equals, clear that out, negative 2 times 4 raised to x. Negative 0.125, negative 0.5, negative 2, negative 8, negative 32, negative 128. These are the same numbers as what we just had. It's just because it's a negative, it's going to be pointing down instead of pointing up. So negative 2, negative 0.125, negative 1, negative 0.5, 0, negative 2, which is our y-intercept, 1, negative 8, and we can't graph 2 because it's negative 32 all the way down here somewhere. Ooh. Okay, we haven't filled in the end behavior, we haven't filled in the range. The end behavior, on the left, this is going towards 0. On the right, it's going towards the negatives. The range is the numbers that are less than 0. Number 5, which you should have done, and if you haven't, you're pausing it before you get the answers. 6, 2, none, 0, 6. We don't know this one yet. All real numbers, y, 0. Okay, negative 2, negative 1, 0, 1, 2, 3. By the way, if you don't have a way to make a table, you're actually just plugging in negative 2 here, which you all have a Chromebook that has a calculator on it, but that's clear. You got 6 times 2 raised to x. Second graph, 1.5, 3, 6, matches, 12, 24, 48. Negative 2, 1.5, negative 1, 3, 0, 6, 1, 12, and we can't graph 224. This one's going towards 0, this one's going towards infinity, and it's the numbers greater than 0. Alright, and we're going to keep doing exponential functions the next day as well. So go ahead and take this if you got it, fold it in half. We're going to glue it on page 52 of your notebook. Okay, so we're going to keep doing this. Try your best. Get the stuff done. Ask questions when you need to. And I will see you later.